Okay, developers, welcome back. In this video, I haven't got any shocking statistics or sensational headlines. The truth is, I recently got hacked, so I'm a little bit sad. I lost some cash, I lost an NFT and an ENS domain name. So what better time than now to talk about smart contract best practices. In this video, we're going to be looking at some precautions we need to take when calling external contracts. If you're new here, I'm Calvin Tora, and on Eat the Blocks, we help Web 2 developers transition into Web 3. Now, the first one we're going to look at is favoring pull over push. Now, in a nutshell, it's putting the risk connected to transferring Ether onto the user. So looking at this auction contract, we're tracking a highest bidder and their highest bid in storage. We then have a function that allows people to place more bids. Inside this, we check the new bid is higher than the one we currently have saved. Once we've got a new highest bid, we send back the previous highest bidder their money, basically a refund, because they've now been beaten out of that top position. Then we are requiring that the transaction to that address is successful before moving on. We then make the new sender the highest bidder, and then we update the highest bid. However, as we just mentioned, issuing a refund could fail. If it does, we now have a contract in an unsolvable state and nobody else can make a bid. This is an example of the push part of the pattern. We're receiving a new bid and within the same function, we're issuing or pushing a refund. Now let's look at the pull version of this pattern. We're going to use the same contract, but we're going to jiggle things around a bit. We're tracking all the same things, but now we're tracking refunds as well inside a mapping. Then in our bid function, we're updating the refunds mapping to track how much the new bidder is sending us. Then we update the new top bidder and their bid. This refactored function only receives funds and doesn't send them out like the last example. Now we can create a withdraw refund function. The user can now manually request their refund. We do our normal checks, we update the state, and then we make our external calls. If the withdraw function fails, it isn't going to lock up the contract and stop anybody else from getting their money. Now, this obviously causes a bit of a hit to the UX of the dApp. We're now making the user execute an additional transaction to get their refund, so the user is pulling the refund. But at least now, they can get their money back. Next up, we have marking untrusted contracts. When we are making calls to other contracts, we should be marking which ones we trust and don't trust. If other developers are using our contracts, it gives them a heads up as to which interactions are potentially unsafe. An easy solution would just to simply name our functions and variables with trusted and untrusted. Next up is avoiding state changes after external calls. We have already touched on this in the reentrancy video where the attacker is able to call our function over and over before state changes are made to the contract. So to avoid this, we just rearrange the function. The typical name for this would be checks, effects, and interactions. Because we can't be sure exactly what is going to happen after an external call, we make all of our checks, then we do our updates, and then we do our external calls. We want the external call to be one of the last things we do inside a function to avoid any nasty side effects. Next is not to use the transfer or the send methods. Both the send method and the transfer method send 2,300 gas to the receiver. Turns out this was to actually stop the receiver from having enough gas to execute any additional work and to avoid reentrancy. But now, according to the Ethereum Improvement Proposal 1884, the gas cost of certain operations has been increased. So this kind of ruins the original backup plan of transfer and send. It's now recommended to use the call method instead. But this now reintroduces the reentrancy problem because we're now forwarding all available gas to the receiver and they can do all kinds of naughty things. This is why we need to keep the checks, effects, and interactions pattern in place, so we can at least protect against things like reentrancy in the most basic way at minimum. Now, handling errors in external calls. Turns out that methods like call, call code, delegate call, and send never throw exceptions. They only return false if there's a problem. If we're not prepared for these, we don't know when to revert a transaction and problems could just snowball. We can use a pattern we've already seen to ensure that we're handling errors if they occur. We can either use a control flow using an if statement to handle the return of a false, or just use require, which if it fails will revert the transaction. Also, if we're using contract calls and triggering functions on that contract, if they throw an exception, that will propagate up to our call and luckily throw an exception on our end as well. Now, I'm not saying that these code examples are to be used in production. These are all just things to keep in mind when writing smart contracts to be a little bit more defensive with our code. Now, before you go, a quick mention that blockchain.com now supports all unstoppable domain TLDs, including those minted on Polygon. This means we can now send and receive crypto with domain names like dave.crypto or alex.nft. Blockchain.com has 81 million wallets and represents 33% of global Bitcoin network transactions. Unstoppable Domains solves the current complications of Web3 onboarding by offering user-friendly NFT domain names. And since I've just lost mine, I'm going to be buying a new one. We'll leave a link in the description below. That's all for this quick video. Thank you for watching and keep those private keys safe. I'll speak to you soon.